In this Miriam do-it-yourself video, we will show you how to apply a LabSOCS efficiency calibration to the Sage well detector spectrum. The spectrum shown here is an americium and cesium spectrum measured in the well of the Sage well detector. The first step in applying a LabSOCS efficiency calibration is to open Geometry Composer. Click on Options, then click on Geometry Composer. When creating a new geometry, there are 3 steps to follow. Click on File, then New. First, select the template you would like to use. Either an iSOCS or LabSOCS template can be chosen. For this presentation, we are going to select LabSOCS. For the Sage well detector, to create a geometry inside a well requires one of 2 custom templates listed, either a custom general purpose beaker or the custom simplified beaker. The custom simplified beaker is the one we're going to use. The general purpose beaker allows you to define 2 different layers of radioactivity. The second step is to select the detector we are going to be calibrating. Scroll to the bottom to select the Sage well example file and click OK. The third step following any custom beaker is to load a particular BKR file. The BKR file allows a custom container that we can fill with activity. Select the BKR file, then click Open. Click the View Drawing button. You will be presented with a schematic of the chosen template as well as applying the specific geometry parameters. For example, parameters 2.1 here talk about the sample fill height. We know this because if we look at the right-hand side of the custom simplified beaker, we see that 2.1 corresponds to the fill height of a particular container. Specify the amount of activity appropriate for this sample. For our purposes, we will use 5 centimeters. Select from the material drop-down list the type of material the sample is. We have chosen water. It will automatically fill in the density of 1 gram per cc. For other matrix materials, it is important to enter a specific density value that matches the density of your sample and not simply use the default density. A description of the sample can be entered next to where it says description. We have entered 5 cm sample in detector well. You can also type a comment. For instance, specify your water matrix. Apply these settings and close the drawing. You will now see an image of a container inside the well detector. We will now use the geometry tree located on the left-hand side of the application to make the detector rendering transparent so you can see the beaker inside. Click on the detector to open up parameters. Click the checkbox next to the word transparent. Now we can see the container clearly within the well of the detector. To also see the sample within the container, you will do the same as you did for the detector. Click on Beaker and check the box next to Transparent. The red value inside is the representation of the sample within the container in the detector. Put on the reference plane for more accuracy to see if the sample is above or below the detector. You want to go ahead and make this flat. This shows that our current sample is exceeding the well. If your physical sample does not exceed the well of the detector, this could be an indicator that the measured fill height was incorrect. Next, we will show you how to adjust the fill height. Changing the fill height can be done in 2 ways. The first way is to click on Edit, then click on Dimensions. Change the value to your new value. For this example, we will change 5 centimeters to 3 centimeters. Click Apply to see update. Click OK to close the dialog window. The second way to change the fill height of your sample is in the geometry tree. Click on Sample. Under Dimensions, next to D2.1, you can change the value and hit Enter to update. The fill height here is from the bottom of the container up to the value that's been defined. To validate that everything entered was successful, click on the Validate Geometry icon. A pop-up will display the text, "The geometry validation completed successfully," if it is successful. To define a range of different energies, click on Edit Efficiency Curve Parameters. Some default values are loaded, but you can also go ahead and select a different list by clicking on Load from File. Select the file of interest and click Open. We have chosen laboratoryenergy.txt. Since the detector characterization for the well detector is valid from 16 keV to 7 MeV, we will remove the 10 keV energy from the energy list. Select 10 keV from the list and click Remove. There are also errors on the right-hand side due to this being part of the laboratory energy list, where they are a little bit tighter than other geometry energy lists. When satisfied with the list, click on OK. Name the geometry file and save it. Complete the step by clicking on Generate My Efficiency Curve. This generates a set of geometry efficiency data points, also known as an ECC file. Click OK to close the dialog window. Return to the well detector and apply this. Click on Calibrate and then Efficiency. Select by LabSOCS and LabSOCS. Click on Select and choose your ECC file that was just created. Then click Open. Click Next. You will now see different efficiency options: standard efficiency, mass metric efficiency, or having a multiplier by the area or length. We are going to choose standard efficiency. Click Next. You will be presented with the input values that were just created in Geometry Composer. The values show the energy followed by the efficiency for each energy and the uncertainty or error in percent for each particular point. Click on Show to ensure they have a good fit. We recommend using interpolated curve for a mathematically generated calibration. As we look from 10 keV all the way up until 10 MeV, it shows we do have a nice set of efficiency data points. We are currently looking at it in log view. It can also be switched to linear view. If satisfied, click OK, then click Finish. If you wanted to, you could save these files as a .calibration file to use in the future, or you can simply continue and apply this calibration for the particular spectrum you are looking at. This spectrum is now calibrated with a LabSOCS efficiency and is ready to be analyzed.
For further assistance, please call 1-800-255-6370.